So this is a big lesson here, solving two-step equations. All right, we just got done one-step equations, so this is twice as much fun. Let's get after it here. All right, our goals today are to use properties to write equivalent equations. What? I thought it was to solve. It is to solve. To write equivalent equations to isolate the variable. Get the variable by itself so then we know what the variable is equal to. Properties, statements that are true for any number, like the commutative property, the associative property, they're always true, no matter what numbers you use. All right, well, we are going to be focusing on specific properties, the properties of equality. If you look in the online textbook at page 121, you can read through those properties, but they basically say whatever you do to one side of an equation, you have to do to the other to preserve the equality, to keep it balanced, to make it equal. So, for instance, if I had a box here and I say, well, that's equal to 3 spheres here. If I were to do something to this side, like double this, then I'd have to double this. All right, that's the property. That's the multiplication property of equality, because I times by 2 on one side and I multiplied by 2 on the other side. And that would keep it balanced. You can visualize that, right? So now, moving on, two-step equations, equations that contain two operations. All right, it was easy when there was only one operation. Easier, because you knew which one to do first. The trick is when there's two operations in an equation, like this example down here, which one do you undo first? So let's give it a go here. Oh, nope, I wanted to do one quick thing here. I wanted to introduce the idea of a term, all right? A term in mathematics, all right? So I'll do it by just sharing an example with you, okay? Typically, we read mathematical sentences left to right, and that's what we do to find terms, all right? So I'm going to make an expression. It's an expression because it's not going to have an equal sign. All right, now, how many terms are there? How many terms? All right, some of you know, some of you are a little confused though. Some of you might say, oh, it's the 2, the x, the 4, the 3, the y, the 6. That's what, 6 terms? All right, well, to clarify, a new term starts whenever you get to a subtraction or addition sign. All right, so if we start from the left and go right, so I'm going to start right here and I'm going to start moving. And a new term starts when I get to that minus sign there. So I cut this off, there's one term. All right, I'm going to keep going. Before this addition sign, I'm going to cut it off, there's another term. Move left to right, and oh, gotta cut it off, there's another term. And boom, there's another term. So that had 4 terms. 4 terms, all right? It's going to be important to notice terms when we have equations. So if we have 4 plus 2x equals 5, now this is an equation because of the equal sign, not an expression. How many terms does this have? Well, the left side at least has 1 term because I stopped when I got to the plus sign, and 2 terms. So that'll help us. If you can see the terms within a problem, it'll help you kind of pull the problem apart so you can understand it better and which thing to undo first. All right, let's get started. 2x plus 3 equals 7. Rewrite the problem nice and neat on your paper. Now we're going to work straight down, canceling out parts of the equation until we're left with just x equals a number. That is the goal. Okay, we're going to isolate that variable by using inverse operations. Now we have 2 operations. We have multiplication right here and addition right here. Which one do we undo first? I like to tell people sometimes it's like the reverse of order of operations. So if we had gems as order of operations, then this is schmeg. Smeg. All right, we're going to undo the subtraction and addition. Then we're going to undo the multiplication and division, and then we'll undo exponents, and then we'll undo the grouping symbols. All right, or what's inside grouping symbols. So it's kind of like the opposite of simplifying things. So solving is kind of undoing everything, whereas simplifying is doing everything using the order of operations. So that's one way to think about it. Another way to think about it is to think of it as separate terms, and then remembering there's one term, here's another term, and remembering that we're always going to get rid of the term that doesn't have the variable in it first. So in this case, the term that doesn't have the variable in it is the plus 3. All right, so that plus 3 is what we're going to get rid of first. And since it's plus 3, we know that the inverse operation of adding is subtracting. So we just directly underneath it, write minus 3. What we do to one side, we have to do to the other. That's the subtraction property of equality. That cancels out. Now we bring everything down. This work, the way I'm showing the work, is important. And I want it shown in your work the same exact way. 7 minus 3 is 4. So now, since we did the same thing to both sides, this equation is still balanced, and we are good to proceed to continue isolating the variable. Now, our next step, all we have left is one operation to undo or use the inverse operation. So since it's multiplying by the x, we divide. Divide both sides. X equals 2. There we have it. Now, of course, I'll show the check here. And that's 2x plus 3 equals 7. And whenever we do the check, we substitute and then solve. No, not solve. We simplify. We substitute, then we simplify. All right? Simplify, again, is using order of operations to just do the operations that are there. Whereas solving, I like to think of it as undoing the operations that are there to isolate the variable. Okay, so anyway, 2 times 2, I substitute in 2 for x, because that's what I think it is down here. And now I'm just going to simplify this side of the equation to see if the left side equals the right side of the equation. So order of operations says multiplication first, and then I can do my addition. Check. Got it. The left side does, in fact, equal the right side when I plug in 2 for x. Let's go. Okay, try it. Pause. Try at least part A by yourself, and then come back and check it out, see if you got it right. Okay, here we go. Now, we have 2 terms. We have the 3x and we have the plus 2. What did I say? We are always going to get rid of the term without the variable first in these types of problems. So let's go back to our red pen and let's start canceling things out using inverse operations. We're going to cancel out the plus 2, the addition of 2 by subtracting 2. Subtract 2. Got to do it to both sides. Properties of equality. 3x equals 18. Now we have multiplication to undo, so we're going to divide. And we get x equals 6. Now you can just kind of mentally check it out. 3 times 6 is 18, plus 2 is 20. All right? So we can circle that with confidence because we checked it really quickly in our heads. All right, next one. Now this one might give you a little problem because the terms are in a different order. The term with the variable comes second this time. So that might be a little bit of an issue. But it still holds true. We're not going to undo the term that includes the variable. We're going to save that for the end. All right, we do have to get rid of this term here. That is a 5. Just hanging out there, 5. How could I get rid of 5 of something? Well, if I want to get rid of that 5 out front, I'm going to subtract 5 because I think of that as a positive 5 there, so I'm going to subtract 5. Now I'm going to put that on the other side as well to keep it balanced. Bring down my 2n after the +5 and the -5 cancel out. And I will have -1 minus 5. -1 minus 5. How's that going to work? So I think of this as going left 1 and this left 1 and this -5 going left 5. So if I go left and left, I'm going to get way far down in the negatives. So I'm going to get to -6. So that's -6 there. Now, I have one operation to undo. I have multiplication to undo, so that's division. Divide, you get n equals -3. All right, now I can check it real quick. Let's do that. All right, I substitute into the original equation for the n, and I have to use order of operations to simplify this. So I get 5 plus -6 equals -1, and then I'm going to add 5 plus -6 is -1. Yay, it works, so I can just circle this confidently knowing that it does in fact make the equation true. And number 2, we got some different things here. We got a fraction involved, we got a variable that's on the right side of the equation. All right, well, let's always go to the side of the variable and find our terms. We got our term here, and we got our non-variable term there. And we're going to start isolating that variable now. So 25 equals 1/4 n minus 3. We're going to start isolating that variable, and we get rid of the non-variable term first. So we're going to add 3 here, add 3. That gets me 28 equals 1/4 n. Now this is from the lesson that we just did. We just had rational coefficients or fractional coefficients. So how do we get rid of that fractional coefficient? We multiply by the reciprocal. Multiply by the reciprocal. All right, so that's cancels that out, right? A number times its reciprocal is 1, so we get 1n. We got to make that into a whole number. That whole number into a fraction, and then multiply, although it's just going to be 4 times 28, which, excuse me, is, what is that? 80 plus 32 is 112. All right, so that gets us 112. And when these cancel out, you get n. So n equals 112. Okay, so we have a little bit of a different type of problem where the variable's on the right side and there's a fraction involved, but I think you guys can do this. You guys can definitely do this. Okay, we're going to get through these couple examples. Try them yourself, and then check your answer. All right, try to rewrite the problems just to spread out your work a little bit. We are going to go to the side with the variable, so that's the right side of this equation. We're going to check out the terms here. We got a 1/2 a, and we got a +9. We typically get rid of the non-variable term first. So let's do that. Let's get rid of that +9 by subtracting 9. And we're going to bring everything down, my equal sign included. We have the 1/2 a. And then -1 minus 9, they both move you left. So that's going to give you a total of -10. Now we have that, we have that fractional coefficient. So we're going to multiply by the reciprocal. Number times reciprocal goes to 1 equals 1. So we get 1a. And we have 2 times -10, which gives us -20. Fabulous. Here we go. Next problem is 2/5 r minus 5 equals 7. What do we do first? We're going to add the 5. I might have skipped ahead a little bit. I'll just go back a little bit for the explanation wise. Right, you go left to right, you stop at that subtraction sign, and then your next term is the -5 term. So that lets you know it doesn't have a variable, so I can get rid of that first. So I add the 5 to, because that's the inverse of subtracting 5. And they cancel out, they go to 0. 2/5 r equals 12. And now we have a fractional coefficient, so we are going to multiply by the reciprocal, or the multiplicative inverse, if you want to be all fancy. All right, 5/2, there we go. A number times reciprocal equals 1, so we get 1r. And we have to make that whole number into an improper fraction, and we can cross simplify, and that gets us 30/1, or 30. Super duper. Hopefully you're cruising along and feeling good about it. Oh my goodness. Put a little star here because this one gets a little wild. All right. We're going to write it down. Follow along. All right. Terms without variables are typically gotten rid of by subtraction and addition. So we're going to start going there. Oh, stop. That minus sign goes with the 3x. That minus sign goes with the 3x. That's an important idea to take into consideration as we do these problems. All right. How am I going to get rid of that 6? Some of you might say add 6 because there's a minus sign, but that minus sign is not with the 6. It's with the 3x. So that has nothing to do with 6. What is in front of the 6 is, or to the left of the 6, is positive. So how can I get rid of that positive term? I can subtract 6. Subtract 6. Make sure you bring down that minus sign with the 3x. All right, because it's basically, these basically equal 0. Okay, so then you get 0 minus 3x, and what would that be? 0 minus 3 is -3. So it's just going to end up giving you, it's just going to end up giving you the -3x. Now, if I subtract that, I get 15. And what operation do we have to undo last? We undo, that's multiplication there, so we got divide by -3, divide by -3, and we have x equals a positive divided by a negative gives me a negative. 15 divided by 3 is 5. Woohoo! Heyo! Lots of things to try now, lots of problems to see how you're doing. Go ahead and try them, and then unpause and see how you did. All right, let's get after this. I'm sure you guys are going to do great. Now, I see my term of 10, a positive 10, and then I have this minus 2/3 p. I get rid of the non-variable term first. So I'm going to subtract 10 because it's a positive 10 there. How do I get rid of a positive 10? I subtract. So bring everything down. Don't forget that negative. And we get 42 on this side. Now we have a fractional coefficient. So to get rid of that, we're going to multiply by the reciprocal. Multiply by the reciprocal. And our number times reciprocal is 1. So we get p equals, cross simplify, 2 goes into that once, 2 goes into that 21 times. I see a positive times a negative, so I get a negative. And I have 21 times 3, which is 63. And the denominators are both 1, so that's just going to be -63 over 1, which I don't need to really write. The one's on the bottom, don't need to write it. All right, I went into my space over here. I'm going to have to write pretty small for this one. Okay, the variable's on the right side this time of the equation, and I'm going to check out my terms here. I have a negative 3x and a plus 2. Now, I'm going to, oops, what am I doing going over there to the side without the variable? I need to undo this plus 2, so I'm going to subtract 2. I'm going to subtract 2. Now, negative 19 and minus 2 both take you to the left, so that's going to be a bigger negative. Negative 21 equals negative 3x. I have multiplication over here, so I'm going to divide using the inverse operation to isolate the variable. Negative divided by a negative is a positive, so 21 divided by 3, 7, and it's positive because 21 and 3 were both negative. There you go. X equals 7. G, let's do it. We've got n over negative 3 minus 2. This is a good one to review because it has a new operation that we haven't dealt with yet in our examples. Okay, so we're going to start going left to right. Look at that. There's one term. Oh, and we have a minus 2. So we undo the non-variable term first, which is the minus 2. We do that by adding 2 and adding 2. Oh, what is this thing? N over negative 3 equals negative 18 plus 2 is going to be negative 16. And now, what operation do we have to undo here? We have division. So it's n divided by negative 3, so we're just going to show to the side here, times negative 3 and times negative 3 on that side to keep it balanced. These cancel out because they're inverse operations. And we have isolated n, and now we have to finish up on the right side here. Negative times a negative is a positive, and 16 times 3 is 48. So we've worked hard, we've hung in there, and now for something completely different. What in the world? All right. So this long division bar here actually is like a grouping symbol. It actually kind of groups the a minus 1. Remember earlier I said simplifying, right? When you simplify, you use gems for order of operations. But when you solve, you kind of reverse it, right? SMEG, it's a cool word. All right, look where parentheses is. Way at the end. All right, way at the end. All right. So this one's a little bit tricky. It's a little bit different, but I'm sure you can handle it. All right. So right now, this long bar is keeping this thing like locked together. We can't get to it until we get rid of that bar. All right. So what we have to do is we have to realize that bar is division. That bar is division. So what are we going to do? We're going to multiply to get rid of it. All right. Multiply both sides. Okay. And what do we have left? A minus 1 equals negative 15. And we're going to continue to isolate the variable. So we're going to add 1 here, add 1 here. We have a equals negative 14. All right, so what was different about that one? It was that long bar that grouped the a minus 1. Now I said, I kept saying, oh, always undo the term without the variable. And you might be thinking, well, why didn't I get rid of the minus 1 first? Well, it's because that long bar, right? That long bar grouped the a minus 1, kind of trapped it, put it in jail. And this 3 is like the guard. You got to get rid of that 3 first. All right, and since it was divided by 3, we multiply to get rid of it. All right, try it yourself, pause, try it, and good luck. We're back. All right, so this long bar groups that guy. So I can't get to that until I get rid of the guard, the number 10 down here. And since it's dividing, I multiply to get rid of it. That cancels out, inverse operation. I bring down whatever didn't cancel out, and I simplify over on this side and get negative 40. Now I have to do the inverse operation to isolate the x, so add 3, x equals negative 40 plus 3. They're going in opposite directions. So the plus 3 takes it back towards 0, 3 spaces, which leaves us at negative 37. Woo! Hopefully you got that one correct. You're able to work through it. And hopefully you'll do well on the practice. Long notes, but important notes. Good luck.